Hey everyone, today I'm going to be understanding Euler's method and I'm going to derive the equation. So as you can see here, I have the tangent line equation. So to find the slope between y1 and y0, I'll move y0 to the other side. And as you can see here, this is the difference between x1 and x0, also known as h. This is also known as the step size. And for m, we can say that this is the slope function, also known as f bracket x comma y. So we'll multiply that into the equation. So then to find y2, you make y2 the subject. And then as you can see here from this equation, we use all the previous values, which is y1 plus h multiplied by the previous value of x and the previous value of y. So the general equation for the Euler's method will be yn equals to the previous value of y plus our step size multiplied by the previous value of x, which is xn minus 1, and the previous value of y. So this will be the derived equation. So now I'll be explaining my Excel spreadsheet and I'll be needing three columns, x, y, and the slope, also known as dy dx. So for the x value, since they say y bracket 0 equals to 1, this means that x equals to 0 and y equals to 1, also known as their initial values. So since I'm using a step size of 0.2, I will use the previous value of x to get the other rows, which is a2 plus the step size. So then I can just drag this down and press Ctrl V. For the y value on the other hand, I will use the general equation, which is the previous value of y in b2 plus the step size multiplied by my slope, c2. So yet again, I can just drag this down and press Ctrl D. So for the slope on the other hand, we'll refer to dy over dx, which is equals to x squared plus 2 over y. So I will use bracket x squared, I'll square this, plus 2 bracket divided by my y value. So then again, I can just drag this down and press Ctrl D. So as you can see here, when x equals to 1, I get a value of 2.430454. So now I'll be solving this equation. So firstly, I'll bring dy on the left hand side and dx to the right hand side. And then I will integrate both sides. So then this will get me y squared over 2 equals to x cubed over 3 plus 2x plus c. So since they say y bracket 0 equals to 1, I have to sub in 0 into x and 1 into y. So after subbing in, I will get c equals to half. So my new equation will be y squared over 2 equals to x cubed over 3 plus 2x plus half. So now they're asking for y bracket 1, which means I have to sub 1 into x. So then I will sub 1 into the new equation, which is y squared over 2, and I will multiply this whole equation by 2. So then I can cancel out these two, and multiply the remaining values. So then I will get y squared equals to 2 over 3 plus 4 plus 1, which is equals to 17 over 3. And then to remove the square, I will just square root this whole thing. And since they said that y must be greater than 0, I will reject the negative value and accept this value, which is 2.3804. So we have an error of 2.10% because the Euler's method actually uses straight line to approximate a curve that bends, and it will slightly overestimate the true value. 2.10% error actually shows that our step size is reliable.